Okay, so we are on the last unit of the year, and that has to do with three-dimensional figures, so like volume, surface area, cross sections. Today we're just going to look at the kind of introduction, talk about some different shapes, and talk about their cross sections, which I'll explain what that is in a moment. So a prism is a solid that has two congruent faces, which we call the bases, so like kind of your bottoms. With all other faces being parallelograms. So here are two examples, and these are called right prisms. So the reason why we call them right prisms is because they need to form right angles. All of these angles here, kind of the ones in the back, on the side, these are all right angles. So we could say every side forms a right angle. So every one of these sides forms a right angle. So let's talk about the parts of a prism. So we have the vertex, the point where two or more straight lines meet. So this would be a vertex, this would be a vertex, this would be a vertex. All of these would be vertices of our prism. Okay, the base, the ends of the prism that are parallel. So our bases would be, in this example, this would be a base, and then this top one up here would be a base. Now it all kind of depends on how you look at it, because if we were to like rotate this, if we were to rotate this figure, well then the bases might change. So let me just see if I could do that. So rotating it this way, well now our bases would be slightly different as we look at this, and this one would be the base. Okay, so it kind of all really depends on how you look at it. An edge is a line or segment that joins two vertices. So this would be an example of an edge. It connects this vertice and this vertice. Another example could be this right here. That would connect this vertice and this vertice. So face is any of the individual surfaces of a solid object. So here we have 1, 2, 3, 4, 5, 6 faces. So this has 6 faces. You have kind of like all of the sides, think about it that way. So here would be an example if I kind of fold this out. Those would all be the faces. So 1, 2, 3, 4, 5, 6 faces. Lateral faces are not the bases, so the ones on the sides would be your lateral faces. Okay, and those are your parts of a prism. So a cylinder, on the other hand, is a shape that's very similar to a prism, except the base face is enclosed by a curve rather than a polygon. So typically the curve is a circle, and the most common is what we call a right circular cylinder. So here's a right circular cylinder, and the bases are circles. So the bases are circles. Okay. What are the two measurements that control the size? Well, the things that control the size would be, one, the radius of the circle. Whoops. Okay, so I could say the radius of the circle. If you make your radius bigger, well then it's going to kind of get wider, this cylinder. And I could say the height. Okay, the radius of the circle and the height. So you can see if I change the radius of this, if I make the radius bigger, it's going to make that cylinder wider. If I make it smaller, it's going to make that cylinder thinner. And then obviously you could change the height up and down. Okay, cross section. A cross section is if you kind of cut straight through an object and it's looking inside of the object. So here would be an example. If I do this like slice, if I cut it through, the cross section would be a circle. So if I go back to this here, so this is showing that it is a circle. Okay, right over here. If I do it perpendicular, well now the cross-section, this cross-section is going to be a rectangle. Okay, so depending on how you slice it, now if I kind of slice it sideways, it's going to be almost more oval, an ellipse. So you can get a bunch of different shapes depending on how you do your cross-section. You know, where you slice it. Think about it that way. So here's a rectangular prism here, and the cross-section here looks like to be pretty much a rectangle. So cross-sections are usually parallel, or actually they could be perpendicular, but they can really be in any direction. So if I go back to this, let's do a prism. Let's make it this. So I can make my cross-section kind of sideways. If I do it like this, well, now it's going to be a pretty interesting shape. I could do it perpendicular. I could do it parallel. So your cross-sections could be any way. So for these, it says to sketch the cross-section, assuming that it's going to be parallel to the base. So sketch it, assume it's going to be parallel to the base. So if I were to do that, I would say this would be a circle, a cross-section parallel, so I would have to kind of slice it through this way. The base is a 1, 2, 3, 4, is a pentagon, so my cross-section will be a pentagon. So notice that the cross-section is going to be the same as the base. So this one I'll have to freehand it. If I do a cross-section, it's going to be the same as the base. So the base kind of looks like this L almost. And then this is like this weird, looks almost like a sponge, okay? And that would be my cross-section, okay? If it's parallel to the base, it's going to be the base. Okay, another 3D figure that we're going to learn about is called a pyramid. So a pyramid is where one face is known as the base, and then the other ones are triangles that meet at a common vertex. So one of them, the bases is like just really, it could be anything. It could be rectangle, it could be a pentagon, it could be a triangle, so we could have a triangular pyramid, a rectangular pyramid, a pentagonal pyramid. Whatever it's called, that represents the base. So for example here, we're going to call this one would be called a rectangular pyramid because the base is rectangular shaped. This is a pentagonal pyramid because the base is a pentagon. And notice all of the other faces in any pyramid is always going to be a triangle. So this face is a triangle, this face is a triangle, over here this face is a triangle, and over here this face is a triangle. Okay, so the cross sections are not going to be the same because as you go up, it's going to get smaller and smaller and smaller. They're going to be similar. We're going to say the cross sections will be similar to the base. Okay, the cross sections are going to be similar to the base. All right. And the last one we're going to kind of just talk about it, and we'll get into more depth with all of these figures. But the last one is a cone, and it's very, very similar to a pyramid, except that the base is a circle. And they all kind of, everything kind of meets up at a point. And the most common cone is what we call a right circular cone, meaning that this height is going to be perpendicular to the center of the circle. Now, a cone is created by rotating a triangle around one of its sides. I'm going to show you that right now. So here we have a triangle, and if we rotate it around this side right here, it's going to create a cone. So there you go, rotating, and that's going to create a cone. I'll just kind of keep rotating around. So we could have cross sections depending on which way we kind of cut it, if we do a parallel, perpendicular, sideways. So it says to just describe it. So I would say that if it's parallel, it's going to be a circle. If it's kind of sideways here, it's going to be kind of like an ellipse. Sorry, you can hear the lawnmower going in the background. Sorry about that. This would be kind of like a parabola. I'm gonna say like a parabola. And if we do it perpendicular, it's going to create a triangle. I'm going to show you that with this little interactive thing. So it might be easier to see here. So if that's parallel, it's going to be a circle. And it says cross-section is a circle. If I do it kind of this way, it's more of an ellipse. So that one, just trying to get it. We have like a triangle. Okay. And so you can see it's getting kind of different shapes here, depending on how you do it. So we have some regions questions here. It has first one asks which is not a possible two-dimensional cross-section of a right cylinder. So the one that's not possible that you can't get is a triangle. So I think we know how to get a circle, we know how to get an ellipse. I'll just show you real quick how a rectangle can be created. So to get the rectangle, you have to do a perpendicular, there you go, a perpendicular slice. So something like this would be a rectangle, okay, if you do a perpendicular. So we can get a rectangle, there's just no possible way to get a triangle. It's just not possible. Okay, so that's 4. So a right hexagonal prism is shown below, which a two-dimensional cross-section that is perpendicular to the base is taken from the prism. So that slice has to be perpendicular to the base, so it's going to go like up and down like this. Which figure best describes the two-dimensional cross-section? So it's a hexagon, not going to be a triangle, not going to be a pentagon, so it's down to either one of these. If we did a parallel cross-section, then that would give us a hexagon, but we're not doing a parallel one, we're doing a perpendicular cross-section. So maybe I'll show you that here. Prism, let's make it a hexagon, 1, 2, so here we go, hexagon. So if it was parallel, like so if it's parallel, that's a hexagon, but we want to make it perpendicular, so that's going to be a perpendicular slice, and that's going to be a rectangle, okay? So for that one, it would be choice 2. A two-dimensional cross-section is taken of a three-dimensional object. If this cross-section is a triangle, what cannot be the three-dimensional object? Okay, so the one that it can't be is a cylinder. So I'll go through why all these 3 could produce a triangle. So first, let's look at a cone. So there you go, it's already there. There's my cross-section. If I do a perpendicular for a cone, that's a triangle. Let's look at a prism. Okay, we can make a triangle if we gotta kind of get it at the corner. There you go. So there we go. That could be a cross-section that creates a triangle. A pyramid. So a pyramid, you know, there you go, triangle's already there. Okay, that could be another triangle. So a pyramid, that works. The cylinder, there's just no way, it's just, you know, there's just no way to get a triangle cross-section for a cylinder. Everything's very circular. So William is drawing pictures of cross-sections of a right circular cone. Which drawing cannot be a cross-section? So real quick, we kind of look at this. That would be if we do a perpendicular. This would be if we did it sideways. And this would be sideways too. We can't get we can't get a square out of a, we can't get a cross-section of a square out of a cone. Okay, and then the last thing, which we did kind of look at, was rotating a figure about itself. That's how you make three-dimensional objects, is by taking a two-dimensional figure and rotating it. I showed you with this one, you know, we're rotating it a triangle around, and that's creating a cone. So this is saying if right triangle ABC shown below right here is rotated around segment BC, what would it look like? All right, well, if we rotate it, this would kind of look something, that's terrible, but it would look something like that, which is choice 1. Okay. If the rectangle below is continuously rotated about its side W, so we're rotating it around this side, which solid is formed? Well, if you rotate this around W, it's going to create a cylinder. It's going to get kind of circular. I'm going to see if I can pull that up real quick. So this is just to show you what happens if we take a rectangle and we rotate it around one of its sides. So we rotate it, rotate it, rotate it. It's going to create that cylinder. It's going to kind of fill it up and create that cylinder. Okay, so that's why that would be 4. Okay, so we have to kind of think about this one. Which three-dimensional figure is generated when the quarter circle, so this quarter circle, is rotated about the y-axis, so rotated around here. So we kind of need to visualize that it's going to come around, but it's going to fill everything else up. And that's going to be a hemisphere. It's going to be kind of half of a globe, so a hemisphere. All right, let's look at 8. So a student has a rectangular postcard, he folds it in half, and he rotates it continuously. So we have a rectangle that is rotated continuously. So taking a rectangle and rotating continuously around one of its sides, that's going to create that cylinder again that I showed you. And that's it. Okay, so this was just a very, an overview of a lot of different things, a lot of different 3D figures. Each lesson we're going to get into each one more specifically. All right? Okay, have a good rest of your day. Bye.